Hi everyone, welcome to Mathematics Foundation classes. Today we are going to discuss about the composition of functions. Composition of functions. Let f is a function from a to b and g is a function from b to c. These are b to c. B two functions. Two functions. F is a function from a to b and g is a function from b to c. Then the composition of functions of the two functions g of f is defined from a to c. This defined from a to c. You can see here, this is the set A and this is set B and set C. F is a function from a to b. F is the function from a to b and g is the function from b to c. Then the composition of functions g of f is a function from a to c. So this is the first function. F is the first function which is from a to b and g the second function from b to c. Then g of f, which is the composition of function, is from a to c. Suppose if x is the one element in the domain of f and its image is fx, is its image in the function f. So fx is the range, whereas the function g, its domain element is fx and range is g of fx. G of fx is the function of the function. So x is the element in the domain and fx is the element in the range. Fx is the range. Then in the function g, fx is the domain element and g of fx is the range. Therefore, f is a function from a to b and g is a function from b to c. These are the two functions. Then the composition of the two functions g of f is defined from a to c such that g of fx is equal to g to fx. G of fx is equal to g to fx. So here the domain of the function f is the set A and a range of the function f is set B. But when in case of the function g, B the domain set and C the range, then the function g of f is from a to c. For example, I'll show an example here. Let f is a function from the real number to real number. Defined by f of x is equal to, say, x plus 5 and another function G is again from R to R defined by G of x is equal to R square. Then how to find out G of f? How to find out G of function, composite function, G of f? In this case, given f of x is equal to x plus 5, x plus 5, and gx is equal to x square. Then composite function g of fx, which is g to fx. So in this case, first we need to find out fx. G of fx, we need to find out fx first. So which is g of fx. So what is fx? Fx is x plus 5. So g of x plus 5. Fx is x plus 5, therefore g of fx, g of x plus 5. And what is function g? G of x is x square. So in place of x we have x plus 5 here. So g of x plus 5 is x plus 5 the whole square. You know the x plus 5 the whole square is x square plus 10x plus 25. So this is g of f of x. Example 2. Let f is a function from 1, 3, 4 to 1, 2, 5. 1, 3, 4 are elements in the domain set, and 1, 2, 5 are elements in the range. And g is another function with 1, 2, 5 in the domain set and 1, 3 in the range set. Here we can see that the range of f is the same as the domain of g. Now here the function f is given here 1, 2, which are the elements in the function 1, 2, 3, 5, 4, 1. 1, 3, 5, 1, 3, 4 are the elements from domain, and 2, 5, 1 are the elements from range. In the second function, first element 1, 2, 5 are the element from the domain, and 3 and 1 are their images in the range. Therefore, we can see in the function f, you know that g of, in the function f we know that f of 1, what is f of 1? Okay, function f of 1, what is f of 1? Function 1, that is 1. F of 1 is 2. And f of 3 is, image is 5. F of 4 is 1. F of 4 is equal to 1. And in the function g, g of 1 is 3. G of 2 is also 3. G of 5 is 1. We need to find out the composite function, that is g of fx, which is g to fx. Let us see what is g to fx. G to fx, first function is f of 1. What is f of 1? F of 1 is equal to, f of 1 is 2, therefore g of 2. And what is the function g of 2? G of 2 is 3. So g of f of 1 is 3. For when x is equal to g of f of x is equal to 1, f of g of fx will get 3. So we get the ordered pair, that is, the answer is g of fx is equal to, first pair we get 1, 3. Then g of f of, second element f of 3. G of second element is 3 in that domain. G of f of 3 is equal to G of f of 3, the value is 5, that's G of 5. And G of 5 in the element here is G of 5 is 1. So we get the second pair, that is 5, 1. So 3, 1, sorry, 3, 1. 3, 1. The third element is f of 4. G of f of 4, which is equal to f of 4 is 1. So G of 1. G of 1 is 3. So we get 4, 3 in the next 4, 3. These are the functions G of f of x. Third question, that is, find the composite functions G of fx and f of gx, the function of the functions. And we have two functions here, that is function f, which is equal to modulus x, and the function g, which is modulus 5x minus 2. So what is g of f? What is g of f? G of f is g of f, which is equal to g to fx, g of function fx. And here we have the function fx, which is modulus x. So in place of fx we replace modulus x, that is g of modulus of x. G of modulus x. But what is function g? Function g is modulus of 5x minus 2. So therefore this is modulus of, in place of x we put modulus x. Then therefore that is 5 of modulus x minus 2. So then g of fx is modulus of 5 of modulus x minus 2. This is g of fx. Then the second one is finding the f of g. Finding f of g, which is f of gx. F of gx. And the gx, we know that modulus of 5x minus 2. In place of gx we replace modulus of 5x minus 2. F of modulus 5x minus 2. In place of gx we put modulus of 5x minus 2 because gx is 5x minus 2. Then f of modulus 5x minus 2. Here the input is modulus 5x minus 2 and the function of the fx is modulus x. Therefore this is modulus of, in place of x we replace 5x minus 2. Therefore modulus of modulus 5x minus 2, which is same as modulus 5x minus 2. We can find out fx is 8x cube is given and gx is x raised to the 1 by 3. G of fx, which is equal to g to fx, which is g of fx. Fx is 8x cube. So g of 8x cube. G of 8x cube. And you know that gx is x raised to 1 by 3. Therefore, which is 8x cube. In place of x we have gx is equal to x raised to 1 by 3 and g of, in place of x we have 8x cube. So 8x cube raised to 1 by 3. 8x cube we know that 2 raised to 3. So which is 2x raised to 3. The 2 raised to 3 is 8. X raised to 3. The whole raised to 1 over 3. So which comes, it cancels. So which is 2x. So g of fx is 2x. And f of gx. F of gx is equal to f of gx. What is gx? X raised to 1 by 3. And what is fx? Fx is 8x cube. So in place of x, we will put x raised to 1 by 3. So which is x raised to 1 by 3. Fx is 8 x raised to 1 by 3 the whole cube. which is 8x. Because f of gx is f of, in place of gx we put x raised to 1 by 3. So f of x raised to 1 by 3 and fx is defined by 8x cube. In place of x we put x raised to 1 by 3. So it is 8 into x raised to 1 by 3 the whole raised to 1 over 3. So that is 8x. Example 4. A function f is from R to R, real number to real number, defined as the function fx is x square plus 1. Here is given only one function here. And we need to find out the f of fx, the function of the function. The function of the function, that is f of fx. F of fx, which is function of fx, is equal to fx is x square plus 1, where f of x square plus 1. Now what is in place of x? We have x square plus 1. Therefore, here f of x square plus 1 is f of, in place of x we put that, f of x square plus 1 is x square plus 1 the whole square plus 1. So in place of x we put s square plus 1. So which is x square plus 1 is x raised to 4 plus 2x square plus 1 plus 1, which is x raised to 4 plus 2x square plus 2. This is the solution f of fx. So okay, now let us review what we learned from the composition of functions. Just to reflect what we learned today. We learned the composition of function, that is, if f is a function from a to b, f is a function from a to b, a to b is a function from a to b, where a is the domain set and b is the range set, and g is another function from b to c. G is another function from b to c. So which is from b to c. B is the domain set here for the function g, and c is the range of the function g. Now just we can see that for the function f, a is the domain, b is the range, and for the function g, b is the domain and c is the range, which means the range of function f becomes the domain of function g. Then here g dot f is the composition of function, composite function from a to c, the composite function from a to c. This is the composition of function g dot f. And you know that the function here, the composition of function of a function here, g dot function, g is a function and f is another function of the function. Actually it's like a two machinery. That first function f is a machinery. Here x is the input. So whatever be the input here, the function, after the function, like the machinery's work, and the range fx, it is the output, which is the output. So input, whatever be the input x here, the function is defined, the function f, and it gives the output fx. Fx is the output. Then the second function, which is another machinery now. Here the input becomes fx. Fx is the input of g. Fx is the input of g, and again it processes the function g works here. After processing, it gives the output. What is the output? The output is g of fx. So two functions here. First machinery is function that is f, where x is the input, fx is the output, and followed by g, the second machine, which works that where fx is the input and g of fx is the output. It's a function of a function, like working in the machinery that. So the first function, x is the input, fx is the output, and the second function, fx is the input of g and g of fx is the output. I hope it is very clear that function is very important chapter. I told you in the beginning that, and if it's, we'll work out some questions here, so it will be clear. Thank you.